This is Team 36, the short ends. Our project is COVID-19 remote monitoring tool. My name is Junli Lu. I will present our project details today, and Eric will demonstrate our application in the second half of the presentation. Many hospitals have been overwhelmed by COVID-19 patient surge and often do not have enough hospital beds to support all the patients. This requires some hospitals to send less severe patients home until their conditions get worse. This leaves the hospital unaware of how their patient is doing unless they show up again later. So our goal and motivation is to help the clinicians to keep track of these patients. As of result, we have created a tool to monitor patient vital signs and conditions remotely, and we also provide patients with remote advices. So the requirement for our applications: first of all, we're gonna provide a dashboard for the patient to see and track their vital signs. We're also able to compute and give them recommendations based on their vital signs and symptoms reported by the patients. We also have a way for the patients to easily connect and disconnect the medical devices for monitoring their vital signs. As for the clinicians, there's also going to be a dashboard, but it has all the patients that the hospital is monitoring, and all the patients are ordered by the severity of their condition. The clinician also have a drill down options to a patient specific dashboard for further details. There's also a way for the clinician to approve and alter the recommendations for the patients. We have 6 members in the team, 3 members for the front end and 3 members for the back end. The front end team members are Eric, and Emily. They all contributed fairly evenly to create different front end pages and components. In addition, they also took other distinct tasks. For example, Eric worked on the logging API endpoint, Eric worked on the mock device and vital data generation. Emily also worked on the Docker files and HDAP deployment. For the backend team, the members are Kathika, Jay, and Chenli. In the high level, we divided the task into Fire, database, and backend API endpoints. Specifically, Kathika worked on creating the Fire APIs using the Happy Java library, so we can have access to the public Happy Fire server to create new patients and observation resources. Jay worked on the account setting controller and database in general, so that we can store the patient information such as username, the password, and the patient ID. I worked on creating all the backend API endpoints, and I developed the patient severity and recommendation algorithms so that we can provide a risk assessment for each patient based on their vital signs and reported symptoms. Now I'm going to go over the research that we have done as a team for this project. The first topic is business justification. We found out that it costs a lot of money for a COVID-19 inpatient, which is about $73,000 on average in the United States, which is a lot for an average American. As the medical resources are limited, we also look into the hospital beds availability. For example, we found that there was not enough hospital beds in Essex County of New Jersey, which only has about 180 beds. That is way below the confirmed cases in the region between September 26th to 31st, which is above 250. The next research is COVID-19 vital signs. We identified the thresholds for the 5 vital signs. For temperature is 100 Fahrenheit for the threshold. For respiratory rate is about 30 breaths per minute. For the heart rate, we did not find enough evidence on how the heart rate associated with COVID-19 patients. For the blood pressure, the threshold is about 140 and 90. And for the oxygen saturation, it's about 92 to 96% for the threshold. The next research, we are looking into the gaps in healthcare domain in terms of remote monitoring. According to Mayo Clinic, they are developing a similar remote monitoring tool for COVID-19 patients, but it's still in the planning phase. Health-Centric Advisor has created a remote monitoring tool for COVID-19 patients, but it does not involve tracking vital signs. It's a text and chat-based application. A company named Fires has been developing a all-in-one biosensor patch that records vital signs, movements, and electrical activity. It's a mobile app for the application. For our application, we can perhaps leverage such a device to complete our solution. This is our team final Gantt chart. As you can see from the Gantt chart here, we have created many tasks for the front end and back end team. We have completed all the tasks on time, and all the tasks are assigned evenly across the team members. Now I'm gonna pass to Eric, who's gonna demonstrate our application.
Thank you for the introduction, John Lee. Hello everyone, my name is Eric Yarbo, and today I'll be giving you a demo of our application, the COVID-19 Remote Monitoring Tool. I'll start us out by logging us in with the test patient right here. I'll use test patient 3, and then I'll log us in with the password 1234. I'll go ahead and log us in. That was wrong. 5. So this will log us into the main dashboard. This is what a patient would see as they're being monitored, and this has different vital signs that are being collected from them from medical devices, and based upon these vital signs it calculates a risk score and recommendations. We also have a number of medical contacts in the bottom. If you click on the drawer right here and click on medical devices, this takes us to medical devices that are attached to a person. We can disconnect, add medical devices. We have like a heart rate, and this doesn't really matter. So I'll click add, this will add it back here. Next, we have the symptom selection right here. Symptom selection is essentially a patient experiences different symptoms, he can input them in right here, and this changes our risk score. So this now, I'll go ahead and log us back out and log back in as a test clinician. And this will be 1, 2, 3, 4, 5, 6. So I'll log us in. So we have this clinician dashboard right here. It has an overview of the different patients that are being monitored. It has different vital signs along the side and risk score as well, and it's organized by the risk score. And if you can see down the bottom, any patient with a risk score greater than or equal to 80 is essentially flagged as being urgent. And if you look at the top right here, we have number counters to make it easier for clinicians to see number of urgent patients. If you click on the side right here and then go to mock data generation, we have our patient data generator right here where you can click on a number of different patients, and then you can essentially mock out these devices, what they would be experiencing in real life. So I'll go ahead and select some values right here, click submit, and then this will send it to the back end. So I'll go ahead and check our clinician dashboard again, and this will take just a moment to update since it's going to our Fire server. In the meantime, we'll go to the account settings right here. This page is for essentially updating different things like username and password, and the recommendation form right here is designed in the future so that our clinicians can manually go in and modify the different recommendations. So I'll go back to our clinician dashboard here. We can now see that the risk score for this patient is really high. You should definitely go to the hospital. As a clinician, you can also drill down into these patients as well, and you get the same view as what a patient would see. So we'll now jump over to our PowerPoint. So that was our demo right there, our project status. So most of our applications working, including the dashboards, the login, logout functionality, the risk and recommendation, and then the mock devices as well. Some of the unfinished things include the clinician ability to change recommendations, as we just said, and this is deployed to HDAP. Future plans, we want to flesh out some of the symptom selection that we saw before. We want to tweak the severity algorithm. We want to add unit testing and provide flesh out some of the settings page, and add things like security, change out Bluetooth instead of having the MOX, and then create a endpoint for medical contacts. And some of the other opportunities, we want to improve the application. Probably want to add like something like MySQL to it, add different charts for the vitals, and we want to allow clinicians to tweak the algorithms from based upon the different symptoms. And that is it for the presentation. Here's some different references. Thank you so much. Hope you have a good day. Goodbye.